Hello everyone. Let's start. So it's my great pleasure here to present EthStorage, scaling Ethereum storage via layer 2 and data availability. So a quick introduction of myself. I'm an active blockchain developer and also Ethereum ecosystem contributor. I have several EIPs, including EIP 404, Web3 URL standard, and also working on Ethereum data availability technologies, and also have several grants from Ethereum Foundation, including data availability, sampling research, and also EthStorage itself. So what is EthStorage? So using a single sentence, that is, we want to develop a layer 2 system that to inherit Ethereum security properties while we can greatly extend the Ethereum storage capacities. So how to achieve that? If you are already familiar with Ethereum scaling solutions, for example, all kinds of rollups, optimistic rollups, and ZK rollups, which aims to verify the off-chain computation with validity proof or fraud proof, we are building a storage-specific rollup. Instead of doing those validity and fraud proofs, we are building kind of a storage proof on Ethereum layer 1 contracts so that we can tell that there are some desired unique replicas that is storing in the layer 2 network. So this is basic idea from rollup, but now we extend this idea from computation to storage. So with that feature, we are able to reduce the storage costs from Ethereum cost to roughly 1 to the 1,000 versus as a store. And we also would like to scale the storage capacity from a few terabytes, which is limited by single node capacity, to petabytes. Everything will be paid by Ether, just like Arbitrum and also Optimism. And we also be able to use the Ethereum security properties so that we are able to satisfy a lot of growing storage needs of these applications, decentralized applications. For example, NFTs, website front ends, and decentralized social network. There are a couple of them. So what is the difference with EthStorage as a storage rollup versus the EVM-specific rollups? So there's a lot of comparison here, but just I want to highlight one line here, is that we are building this proof of storage algorithms that can be verified on layer 1 so that there's some desired physical replicas that is stored in the layer 2 network, rather than right now there's no such enforcement of EVM-specific rollups, including optimistic rollup and ZK rollups. So this is the one key major difference of the EthStorage would like to achieve versus existing scaling solutions. So with EthStorage, we believe we are able to enable a lot of interesting applications. For example, it can be a long-term storage solutions for existing rollups so that we are able to save all those transaction records forever, like optimistic rollup or ZK rollups. And it can also enable fully decentralized front ends with rich dynamic websites that return from a smart contract rather than a static content of the file, which right now Filecoin RV is now able to do that. So we will tell how we are able to do that in the later with our other technologies. And another application is that it can be a native storage for NFTs. So when the user buy the NFT, it not only owns a smart contract and have this ownership of this token ID, but also the corresponding data that is also be able to be verified on chain that is stored in the layer 2 network with some replications. So how to achieve that? There are a couple of technologies that we either built on and also developing to solve this problem. First, there's a proof of publication problem that we are able to allow a large amount of data that can be uploaded on the blockchain with the same mainnet security. How to achieve that? And this is basically the data availability problem that Ethereum is solving, especially by dank sharding. The dank sharding will increase the data throughput to roughly 20 times versus the current Ethereum. So which will greatly solve this data availability problem or proof of publication problem, and which we have a research grant from Ethereum Foundation in working in this area. Once the data is available on chain, the next step is how we are able to storage this data in an off-chain network or layer 2. And this is the proof of storage on large dynamic datasets on another research that we are working with Ethereum Foundation with the grant support so that we are able to support petabyte capacity with rich semantics in terms of CRUD, create, read, update, and delete. And lastly, once we are able to upload a large amount of data and store this data in the network and be able to manage by smart contracts, we need a way to directly access those data that are managed by smart contract and the underlying storage layer. And that's why we propose the Web3 Access Protocol, which is a decentralized access protocol to the dynamic web contents that are hosted by smart contracts. So let me go through some details. So the famous dank sharding is proposed to increase the Ethereum layer 1 data upload speed using some KZG commitment and Rich Solomon code. The current spec is able to offer 20 times of performance versus core data, which all these optimistic projects or Aurora projects are using. And with this bandwidth, dank sharding will create 1.5 terabytes of data per week. That is roughly 80 terabytes per year. However, in order to relieve the validators, the consensus of Ethereum that as an upgrade for the dank sharding will expire this data in just 1 month, which means that once the data is being uploaded to the network, Ethereum network, it will be deleted in 30 days. And so we do some research so that we are able to optimize, for example, Rich Solomon code reconstruction to 3 times. And you can also find the research result in the Ethereum Research Forum. So now, with DA and dank sharding, now we are able to upload a large amount of data temporarily, just in 1 month. And how we are able to build a layer 2 system to store this data in large scale at much lower cost. So here is a diagram of how the EthStorage works with DA. Now with data availability, we will have a new object called blobs. So blobs is defined in EIP 4844, or called total dank sharding. And blobs will have a hash that is into the transaction, which is able to be accessed by this contract. However, the blob itself is only available to the data availability network. So once this transaction is put on chain, the contract will have the corresponding data hash that EIP 4844 is at. There's an OP code called data hash. And then the corresponding data, which is available in 30 days, will be able to be retrieved from data availability network in the Ethereum. So the storage contract will notify, you will basically this process this transaction. We know, oh, there's a data that is going to be stored in the layer 2 network. And so those layer 2 network storage providers will be notified that, hey, there's a new data, it's updated to the smart contract, and the user would like to pay this storage fee with this data, and the corresponding data blobs is available in the data availability network. And this is how Ethereum DA works. And with that, the layer 2 network will retrieve corresponding data and store locally. And at the same time, why it store this data? And that's because the contract will offer the money. Say, hey, for those storage providers, if you can prove you have this physical replica of this data, and once the proof is successfully generated, then I will reward those storage providers with the Ether that the users paid. So they will compete for this generation, and once a successful proof is generated and submitted to the blockchain, that is the storage contract, and the corresponding Ether will be distributed to the storage provider. And then the key problem is how we are able to build such proof system, and also its on-chain verification on large dynamic layer 2 datasets with an Ethereum layer 1 contract. And this is the Ethereum grant that we just received last month to address this specific problem. And this is kind of a new problem that we're facing because like Filecoin, RV, they are solving more kind of like static files, static objects. So, but if there's a large dynamic ones, how we are able to solve this problem? And so the keywords, one is dynamic. So the data, suppose I'm a user, I upload an article onto the blockchain, I may modify it, I may delete it. It can be frequently changed. And further, the verification is on top of layer 1 contract. There is no protocol upgrade is required, just like ZK Snark, ZK rollup. And the key technology that we are developing is called ZK non-SQL or ZK key value store. So that we are able to use ZK and Snark technologies so that we are able to basically compute some random sampling off-chain, but with a very succinct proof submitted on the on-chain tells that if a data provider does not provide corresponding replica, then it will not be able to pass this proof in a high probability and then collect corresponding reward. And this is basically ideas that we are building, also key ideas between the EthStorage to solve this problem. And here is a quick comparison of what EthStorage doing versus Filecoin or RV. So EthStorage is more kind of like an extension of Ethereum current object codes for storage. As store and as load with CRUD, key value store, and different properties including on-chain EVM programmability. For example, the contract can tell, oh, I want to delete this file, I want to change this state blob, I want to, for example, read this part. And at the same time, Filecoin RV, they are more optimized for static files, which can be huge, super large, and even much cheaper. Another unique feature of EthStorage is that it's completely compatible with Ethereum wallets, development stack, like Hardhat, MetaMask, all this. So from developer perspective, it just requires very minimum knowledge, and then it can deploy further applications on top of that to utilize the power of EthStorage. And this application can be decentralized social network, decentralized like MFT, or any other kinds of Web2 application that we can imagine. And with the data that is now available in the layer 2 storage network, how we are able to achieve them? And that's why we propose Web3 Access Protocol. It's defined in ERC 4804, which was finalized yesterday. So very good timing. And it's also registered at IANA. Its basic idea is similar to HTTP, but instead of locating centralized resources, it's to locate decentralized resources hosted by smart contract, and also it supports multi-chain. So the authority here is replaced by name or a contract, and there's a corresponding way to tell how to call this contract and return this the content. And we have an Ether bounty for any developers, hackers, that is be able to deploy their contract and use and then create dynamic web content using Web3 access protocol. So we do some early experiments on these ideas, and we collect a lot of interesting feedbacks from community. For example, we upload Vitalik block, which has 40 megabytes of data, and on Arbitrum Nova, which causes roughly 0.13 Ether. And we collect a lot of feedbacks, 100 upvotes, and I think 20 or 30 comments saying, wow, this is an interesting idea, how to solve this problem, how to solve the storage. Yeah, welcome everybody to take a look and contribute and comment. And we are also exploring more aggressive ideas. For example, one idea is called decentralized Git, so that we are able to put the diff as a blob in the EthStorage. At the same time, we maintain the relationship of this commit using Ethereum EVM. So that now we are able to build a decentralized Git without any centralized component. For example, we can build Ethereum on top of Ethereum. So there are also a couple of projects in terms of decentralized dropbox, decentralized Craigslist, and decentralized wallets that without serverless wallet. And so we believe with all this infrastructure, we can build a much richer Web3 applications where Ethereum drives the most innovations. And we are able to have this scalability to serve all the people in the future. And it's fully decentralized. From front end, we have Web3 to the application logic with the Ethereum layer 1 and layer 2. And it's a storage as the underlying storage layer to solve this storage issue. And so here is a couple of timeline of this storage. In this year, especially in the early this year, we are going to launch another testnet with almost full features that I just described with like maybe 10 terabytes or 100 terabytes data so that we can experiment all those decentralized Git or decentralized Wikipedia, all kinds of crazy ideas using EVM and storage. So we welcome community members to join and become either validator node or storage node and develop amazing applications on top of that. So thank you very much for attending my talk. So I have 1 minute left. Happy to answer some questions. Any questions? Sure. So the data is encoded in a storage node so that we can make some unique proof. Otherwise, we have one copy of data that how we are not able to prove this data has been physically stored in multiple locations, physical locations. For the encryption perspective, since this is a public storage, so we rely on user to encrypt its data using its, for example, maybe a private key derived key to perform symmetric encoding. So this is probably more like rely on application. And we have a decentralized drive, private drive, that implement that feature. So we're free to use it and have a try. I think I'm running out of time. So many thanks for the, I'm running out. So we can discuss later. Yes, sure. Thank you very much.